3 grams of zinc granules were placed in a flask, then 100 centimeters cubed of hydrochloric acid with a certain concentration is added. The mass of the flask and its contents is then measured at regular intervals. The graph obtained by plotting these readings is shown. So the mass decreases until it stabilizes, which makes sense because one of my products is a gas, which means that that gas is not disappearing, but going into the atmosphere and going away. So the reaction between zinc and hydrochloric acid is represented, and they give you the reaction. What is the dependent variable in this experiment? So what am I measuring? I am measuring the mass of the flask and its contents. Explain why this reaction is not an equilibrium reaction. We land up with a situation where it is clearly an open system. Remember, for equilibrium, we need to have a closed system. So this is an open system where one of the products is able to escape, so it won't reach equilibrium. What is indicated by the portion of the graph that is parallel to the time axis? Well, we've just said it's not an equilibrium. So we have, at that point, we have run out of either reactants or products, at least reactant 1 or reactant 2. One of them is a limiting reagent, and therefore the reaction has reached completion. Use calculations to determine the limiting reagent for this reaction. So the first thing that I need to do is I need to decide what is my number of moles of zinc and what is my number of moles of hydrogen chloride or hydrochloric acid. So first for zinc, I'm going to say mass over molar mass, because I've been given a mass. So it's 3 over 65,4. And that turns out to be 0,0459 moles. And then for hydrochloric acid, the number of moles is equal to concentration times volume, 0,5 times 0,1, and I land up with 0,05 moles. Now we know that zinc reacts with hydrochloric acid as 1:2, so therefore I land up with if I were to go 0,05, I would then divide in half and I get 0,025. And that does work because 0,025 is less than 0,0459. And therefore, hydrogen chloride is your limiting reagent, or hydrochloric acid is your limiting reagent. What volume of the hydrogen gas is produced in this reaction? So I must now use the number of moles I've got of the limiting reagent in order to work out the rest. So I'm going to go HCl has a relationship with hydrogen as 2 is to 1. That's 0,05 is to 0,025. I've had to divide that in half, and I therefore land up with that many moles of hydrogen. But I'm interested in the volume, which means that I need to now use, it's at STP. I don't know if they said it. No, they didn't, but they should have said it was at STP. V is equal to number of moles, molar volume, 0,025 multiplied by 22,4, and that's equal to 0,56 decimeters cubed. 3 separate changes are made to the above conditions in 3 separate experiments. Copy the graph into your answer book and draw graphs where applicable in each of the following. Label each graph clearly with the appropriate number. So the first one asks me what happens if I put some zinc dust in instead of zinc granules. This whole thing is going to go a whole lot faster. So I'm going to make this zinc dust. So it reaches, the time that it reaches completion is much shorter, and we'll call that dust 4.6.1. Then it asks me the acid is heated. That is also going to land up being a much faster reaction, and so it's also going to come down fast and reach completion sooner. Down and across. What's important is that you start at the same point and you end, your completion is still at the end. It doesn't really matter which of those was steeper as long as they both are faster than the original. Then they ask you what if I used a lower concentration of the acid, because my original concentration was 0. 0,5, so this is a lower concentration over here, and therefore it will go slower. So I'm going to end up starting at the same point, and it will take longer to reach completion over there. Methanol is manufactured by compressing a certain mixture at a certain pressure, and then we put it over a zinc oxide catalyst, and here's the reaction given here. It is an endothermic reaction because of that plus sign on the delta H. What is the chemical formula for zinc oxide? You are expected to know that zinc has a valency of 2 and oxygen has a valency of 2, so it will be ZnO, which is fortunate. What purpose does the catalyst zinc oxide serve in this reaction? It is going to lower the activation energy and hence speed up reaction. It's the purpose, it's not what is, you can't say that it's a catalyst because that's what the question asked, so you need to explain what a catalyst is. Then it says draw a neat sketch graph of potential energy versus reaction coordinate for this reaction without zinc oxide. Draw a second curve showing it using a dotted line showing the same reaction with zinc oxide. Clearly indicate the heat of the reaction on your graph. Also label the position of the activated complex or the uncatalyzed reaction. So the first thing is we need to know what to label. That's potential energy and that's reaction coordinate. We then need to put the classic shape of an endothermic graph in, and that would be uncatalyzed. Here is my delta H value from the difference between the energy of the reactants and the energy of the products, and that is my activated complex. Now if I want to put in the catalyst will lower the activation energy, and you'll have a little curve that looks something like that. The reaction is allowed to reach equilibrium. What would the effect of each of the following changes on the equilibrium concentration of methanol be? Explain each answer in terms of Le Chatelier's principle. So, first, the temperature is decreased. So we're going to write the bullet points that are needed. So the first thing is temp decrease favors exothermic would be better. To try create heat. In other words, that's Le Chatelier's principle. It tries to reverse the current situation. So what is going to happen is we will therefore favor reverse, because the forward is endo. Reverse, which is, by the way, the exo reaction. And therefore the concentration, because the question is what is the following on the equilibrium concentration of methanol. If I'm favoring the reverse, I'm making less methanol, so the concentration of the methanol will decrease. What if I increase the pressure at a constant temperature? So increase in pressure favors least gas moles to try have less pressure. There are 3 gas moles to 2 gas moles, therefore forward favored. And therefore, we would find that the concentration of the CH3OH, the methanol, would increase. And finally, let's go down to the bottom here. The concentration of hydrogen gas is increased. More reactant favors forward to try and use it up. Therefore, forward favored, therefore the concentration of methanol increases. We've got 12 moles of carbon monoxide and 8 moles of hydrogen. They get placed into a certain volume and gets heated to 300 degrees. When equilibrium is reached, we are given a number of moles of hydrogen. Calculate the value of Kc for this, and we are just going to use a simple Rice table on this. So the first thing is to write down my balanced equation. CO plus 2H2O, H2 gives me CH3OH. What have I been given? I know that my mole ratio is 1:2:1. Those are just these numbers in front. Then I know that I started, initially, I had 12 moles of carbon monoxide, and 8 moles of hydrogen, and nothing for the methanol. Then I would have used, let's do that, none of the methanol. I don't know anything about the other two. At equilibrium, though, I have been told that there are 2,25 moles of hydrogen left. And I'm going to go volume and concentration over here, and let's see what comes out. So the first thing is that how much did I use? If I started with 8 and I was left with 2,25, I must have used 5,75. The mole ratio is 1:2:1, so I am going to say 2:1:1, and therefore I halve 5,25 and I get 2,875. 2,875. Now I take the 12 and subtract 2,875, and I land up with 9,125. I now have a number of moles at equilibrium of everything. The volume of the container I was told was 600 centimeters cubed, which I need to convert into decimeters cubed, and therefore that's 0,6, and I am now going to calculate these concentrations. Concentration is number of moles divided by volume, number of moles divided by volume, number of moles divided by volume, and so my concentrations turn out to be equal to 15,21, 3,75, and 4,79. Then what is Kc? Kc is equal to concentration of products over concentration of reactants raised to the power of the coefficient, and I substitute in those values, so it's 4,79 divided by 15,21 and 3,75 squared, and I land up with 0,02, and it has no unit because it is Kc. And then the next thing that they ask me is, what would happen to Kc if the temperature were increased to 400 degrees? Explain your answer. So if I'm going to increase the temperature, I am going to favor the endothermic. Increase temp favors endo. Therefore, forward favored. More product increases Kc, because obviously this number would get bigger and therefore the whole of Kc would increase. In the Haber process, the reaction to make ammonia is given to a container. The container is sealed, the gases are added. The graph below represents the changes in the number of moles of the gases in the reaction vessel over 35 minutes. Define dynamic equilibrium. It is when the rate of the forward reaction and the reverse reaction are equal in a closed system. Don't forget, you have to have a closed system. And you talk about the rate of both reactions being equal to one another. Give one advantage of performing the process at such a high temperature: you would have a faster rate, and therefore the reaction would take place faster. What change was made to the equilibrium mixture at the time 10 minutes? So something happened over here. Wow, check out that spike on the hydrogen line. That means a whole lot of hydrogen got added. Let's check. If I added hydrogen, I would favor forward. So in other words, the hydrogen and the nitrogen would go down after the change. Hydrogen does go down after the change, nitrogen does go down after the change, ammonia does go up after the change. Good news. So that must have been the change, so we must have added some H2. Explain why the number of moles of various gases changed as they did after the change was made. And that's just what I explained right now. So adding more reactant favors forward. Therefore, H2 and N2 concentrations decrease, and the NH3 concentration increases. At a time of 20 minutes, a further change was made to the equilibrium mixture, which brought about a permanent change in the equilibrium constant. So that has to now be temperature. We know that. So I'm not sure what temperature, but it must be a temperature change. Explain the change that must have been made and state how this change would have affected the equilibrium constant, increase or decrease. So the first thing is I say only temperature changes Kc. So let's start with that as a definition. At 20 minutes, what has happened? I've got less H2 and less N2 and more NH3. So in other words, forward was favored because I made more product. We know that forward is exo because that was given to me. And therefore, what do you favor? What favors the exo? It must be a decrease in temperature.